Hello, everyone. Thank you all so much for joining in today. We are very, very sorry for yesterday's fiasco. So, we do hope that you are here, all of you, to learn today. So, welcome, everyone. So, we still have a few participants joining in. So, we will be waiting for 2 more minutes before everyone. And So moving on, before actually starting with the webinar, I would like to give you a rundown of who we are, what we are doing today, and what our motive was behind organizing this webinar. So this webinar was organized by Girls in Tech Nepal, which is the Nepal chapter of an international nonprofit organization, Girls in Tech. So Girls in Tech's main motive is to empower women in the field of technology and in professional fields. So, carrying our HQ's motive and our Nepal office's motive, we do conduct different events that are both targeted for male and for female participants for their empowerment, for enlightening them, for increasing their knowledge levels. So our idea behind the webinar series that we are doing from Girls in Tech Nepal is to utilize the time of this pandemic, to utilize the time of lockdown to learn something new, to gain knowledge and be productive. So I do hope that everyone here today will be able to learn something new from our very talented facilitator today. So moving on, I would like to introduce you all to our facilitator. So our facilitator is Haritha. He's the Microsoft MVP in artificial intelligence. He is also a PhD candidate at La Trobe University in Australia. So, so over to you, Haritha. So we do hope that you will give us an awesome session today.
Hi, thank you, Sree, and welcome everyone for the session on what's inside AI. And as we planned yesterday, we had some circumstances of doing the session further. So we are back here today, and we'll start and we'll move forward with the session. So in my session, you are okay to ask questions. So in as Sree mentioned, you can ask the questions in the conversation section or in the Slido you have. So Srishti will moderate the questions for me. So answer the questions when the session is going on. So a little bit of an introduction about me. I'm a graduate researcher of La Trobe University here in Melbourne, affiliated for Australian Institute of Sport. So what I do there is I'm doing a research in deep learning, specifically in computer vision, and more like applying computer vision for the area of sports analytics. I'm also working as an independent consultant in data science and machine learning, as well as two blogs on my blog called Nadi Speaks, and also serving as a Microsoft MVP in AI category. So we'll move forward and see what sort of things that we're going to discuss today, and what sort of things that AI can actually do. Uh, so I'm pretty sure you can recognize these images because the first one is a Tesla and the second one is the Dota 2 game, if you have played the game. And the third is the Google Home that you have in your homes. And the third one is Boston Dynamics, their famous robots. So as you know that Tesla is having their autopilot feature that is enabling to drive through the highways as well as on the car parks with autonomous driving skills. So this is one of the major advantages of computer vision plus AI. And if you know Dota 2, it's a pretty hard game to play. But recently, Elon Musk and a team, they built an AI system that can beat Dota 2 world champion. That means the AI was able to beat the world Dota 2 champion. And Google Assistant, starting from just switching on and offing a light and keeping your alarm. It is able to understand your voice as well as it can understand whether it is you or your friend. And the Boston Dynamics robots, they are using AI to understand the terrain that they are working towards to, and they can do many activities using AI-powered algorithms. So these are some top-notch applications that artificial intelligence is being used everywhere. Because of these things, AI has been a buzzword in everywhere, in internet and in courses, in universities, everywhere. AI has been a very big buzzword today. So we're going to look what actually AI is and what are the terms that go on with AI and what sort of things that we can actually do AI. And at the end of the session, we're going to see as a developer or as an undergraduate, how you can come into this area, how you can become an AI developer or a machine learning developer. So we're going to look on that too. Right. So the term AI is not a new term actually. This term came to the scene back in like 1950s where people were thinking, okay, we have the algorithms that do the functions based on the logic that we give for the system. But is there any possibility that we can make systems that can think like humans, or we can build some systems that can think and get decisions like humans? So that was the start of AI. If you know, there was a famous guy called Alan Turing who actually gave an gave a framework that talks about what actually a AI system is and how to identify that is a AI system is. That was named as Turing test. So it came back in like 1950s, and the machine learning algorithms, the so-called machine learning algorithms that got some feedback from mathematics as well as statistics, that came back in like 1980s, and people used those machine learning algorithms to do some tasks. But though the term like neural networks also came in this 1980s, the computation power that people had to process these algorithms were pretty low because it was pretty hard to find computers with such speed to do this kind of complex algorithms, to solve this kind of complex algorithms. In like 2010, the rise of cloud came, the cloud computing paradigm came, as well as the GPU computing came into the scene. So people thought of, okay, we have the algorithms that cannot be used with simple computation power. So now we have the computation power, right? This is the time. So we can move forward to more complex algorithms, which is going to be deep learning algorithms or the deep neural networks. So as a whole, AI is the big term or the bigger picture, and inside that, machine learning is a sub part of AI, and deep learning is a sub part of machine learning. This need to be super clear for you because deep learning is not all about AI. So deep learning is only a sub part of artificial intelligence or AI. So this need to be crystal clear for you because there are some confusions going on these terms. Right. We talked about AI, machine learning, and deep learning. On top of that, there's another thing called data science or the data science. So what data science is? Data science is combination of three aspects. So data science is having a part in computer science, as well as in maths and statistics, as well as in the domain or the business knowledge. We'll say you are running a business entity which is generating a hell a lot of data. We'll say you are running a supermarket or a franchise shop that collects the data about the customers as well as on their sales every day. So this is a scenario where you can apply this your business knowledge with the data that you have and get the support of math and statistics as well as the computing and the IT power that you have. And the combination of these three is going to be a data science application. So if you want to become a good data scientist, you should have an idea on all these three aspects. You should not want to be a very good in maths and statistics or very good in business knowledge, but you should have an average knowledge on both, like all these three things. That means a data scientist is a balanced person which is having a good idea on computer science, maths and statistics, and the business knowledge. Right. So it's so hot. Machine learning is so hot. Everyone is talking about machine learning, what machine learning is and all. So if I give you a simple explanation on machine learning is the way of learning from the data patterns that we have and do a prediction based on that. So the data patterns that we have should be learned from the past data that we have collected and labeled. If you don't have the ability to label the data, you must have to go for a separate kind of machine learning paradigm that is called as unsupervised learning. So in the next slide, I'm going to explain one by one what sort of machine learning paradigms and what sort of machine learning activities that you can perform and the main types of machine learning. So machine learning, basically, this is a very vague and very broad division. So can be divided into two sections as unsupervised learning, and the second is supervised learning. So in supervised learning, we develop predictive model based on both input and output data. That means, in the simple terms, in supervised learning problems, the data that we have is labeled, right? But in unsupervised cases, we don't have the privilege of that labeled data. We only have a set of unlabeled data that we need to find the patterns between those data. So one simple example of unsupervised learning, machine learning problem is clustering. And when it comes to supervised learning, we have classification as well as regression. So we'll move forward and see what these terms are: clustering, classification, regression, and what those terms are. So if you have any problem by so far, you can just type in the conversation section or in the Slido, and we can have the questions while the session is going on. Right. So this is about supervised learning. So Srishti, do we have any problems so far?
So yeah, I do have a question about your expertise. So we have someone who wants to know about the research that you're doing right now. So I do think that you will touch on the subject at the end of the session. So we might deal with at the end of the session. So dear participants, if you do have questions about the session, about the topics that Haritha has discussed till now, please post them on Slido. I will surely relay them to Haritha, and Haritha will be able to answer you. So, okay, I am checking on what questions we have. Okay, so I see a lot of questions. Okay, so we have one question. So it reads as, okay, so machine learning acts. Okay, so this question is a bit confusing. Okay, so the person is asking that what is the main difference between artificial intelligence and machine learning?
All right. Yes. That's a good question. So main difference between artificial intelligence and machine learning. So I'm going to go back to this slide. So artificial intelligence is the wide and the broad term. So there are many concepts and algorithms as well as methods that can build artificial intelligence systems. So machine learning is only a part of those algorithms that can build AI systems. There are many other algorithms such as genetic algorithms, hidden Markov chains, and so forth, knowledge bases, and knowledge reasoning that we can do from the programming languages like Prolog. is also falls under these artificial intelligence. First order logic, second order logic, and all those logic operations also fall under artificial intelligence. But inside artificial intelligence, machine learning is a subpart that they can build AI systems. So I guess I have answered your question. So AI is the big term, and ML is a subpart inside that.
Okay. So we do have another question. So Haritha, what do you think is a successful application of AI?
Unsuccessful or successful?
Successful.
Okay, yeah. There are many successful applications in AI or AI. One successful application is voice recognition that is doing in Siri, Google Assistant, and Cortana and those things. That is one success application, as well as you may have seen the facial recognition that is doing in iPhones, as well as in many surveillance applications. Those are like two major applications where AI has been successful.
Okay, thank you so much for your questions. So these are all the questions we have till now. So you can move forward with your sessions. And to the dear participants, if you have questions while Haritha is presenting, please drop them on Slido. We will dealing with your question throughout the session. So thank you.
All right.
See you,
So,
Haritha.
yes. So we are coming back to the place where we have stopped. So one thing is the first thing, supervised learning. So we discussed there are two aspects. One is the supervised learning, and the second one is unsupervised learning. In supervised learning, we have set of data that has been labeled. So this is a simple example, very funny example. So let's say we have a set of images of ducks and some other animals. So some other cartoon characters. So we have labeled ducks as ducks, and the Mickey Mouse and the rabbit or the Bugs Bunny as not ducks. So we have the supervised machine learning predictive model that is able to build a system that can identify ducks and animals which are not ducks. So this is a simple way of representing which supervised machine learning problem is, where the data is having their own label. The difference between supervised and unsupervised is there's no labels in the data. If you look on the left hand side, the data that we have or the images that we have doesn't have any labels. So what we have to do is we have to have an unsupervised learning, like machine learning algorithm that can figure out what are the differences or the similarities between these data, and they should have the ability to divide them into two sections or more sections based on their similarities and the differences. So this is a good example of showing what an unsupervised machine learning problem is. All right. So we talked about some unsupervised and supervised machine learning problems, and we'll say what sort of actions or what sort of things that we can do with this. Because I have seen in many cases, like in undergraduate projects and all, they think, okay, for the final year project, we're going to add some AI or we're going to add some ML component because we're going to have more marks on that. So that kind of thing is going on. But we have to see what sort of problems that we can solve with this. So the first one is if that is a classification problem. That means we have two or more classes that we need to divide those classes. We can use machine learning on that. So we can say if this particular data or if this particular image or if this particular item is belongs to class A or class B. So that is a simple machine learning problem that is called as classification. So the classes can be two classes or more, right? The two class classification problems has been known as binary classification problems, while where there is many classes that is known as multi-class classification problems. So the first task that we can do with machine learning is classification, and this might be the most uh, like famous machine learning problem that is out there in the market right now. The next thing is whether to find which data is weird. This is called anomaly detection. So if you have a set of images and you have some anomaly coming up, you can identify it using machine learning. We'll say you have a production line that produce milk bottles, and you need to identify which milk bottle is having a defection, which milk bottle is having a leakage. You just get a set of images, and you have to find out which milk bottle is having a leakage. So that is a perfect anomaly detection machine learning problem. And the other type that we have to look on is regression. I'm pretty sure in your high school mathematics, you know the idea behind simple linear regression, which comes up with a simple algorithm that y equals mx plus c. So that is the most simple way of dealing with regression. So you can solve machine learning problems that with linear regression as well as with nonlinear regression. We'll say one of the examples you can get here is predicting the future sales or predicting the future temperature. We'll say you need to predict how the sales is going to be in the next month based on the data that you have for 2 years. You have to think of how many tourists will come for base camp in the next year based on the past data. Those are some of the things that you can do with regression machine learning problems. So far, all these three problems we discussed, that means classification, anomaly detection, as well as in regression, all these three are supervised machine learning problems. So the next thing I'm going to discuss is clustering, which is going to be an unsupervised learning problem, unsupervised machine learning problem. What happens here is that looks on the data and see what are the similarities and the dissimilarities between those data and make them into separate sections or the separate bags. So in this one, you can think of the ways like you have set of toys which is not labeled, and you get the images, and you do build a machine learning algorithm or a machine learning model that can cluster which toy this is and which toy this is. This is a very good example for clustering algorithms. Right. The next thing is a very new paradigm that came a few years back. This is called reinforcement learning. So reinforcement learning is a machine learning paradigm where you learn with the experiences and the rewards that you're getting. This is the way where the robots and all those things are operating, as well as how the game playing AI is operating is on this reinforcement learning machine learning algorithms. If you have seen the news about AlphaGo, there was a system that Google built that beated the AlphaGo world champion in China. There's a game in China called Go. So what they have done was they have built a reinforcement learning algorithm that can beat that kind of strategic game. If you search in the internet, you can find out many examples that are reinforcement learning algorithms that has been built for play chess kind of board games. So this is a term that's coming in, and I'm pretty sure reinforcement learning would be a huge hit in the future and do some miracle stuff. Not sure how it is going to end up, because it's kind of like learning as an infant. You know how the infants learn, right? So they learn from the experiences and the rewards. Rewards means if we smile, if he does something good, so that's a reward that the infant is getting. So that's how the same method, how these algorithms, that reinforcement learning algorithms work. All right. So I'm not sure whether you can see this slide or not, but I'm going to share this slide so you can have a look on this. So this is kind of like a broad view about machine learning algorithms. So I'm not going to explain one by one because that's going to be too technical. So there are many algorithms out there to do those tasks. That means if you get clustering, there's a set of algorithms that you can do clustering on with that. And if you get classification, there's a set of algorithms that you can do classification with that. Same as regression and all those things. So you have to find out which algorithm is suited better for your data and for your context. So that is the decision which data scientists or the machine learning engineer should take to see which algorithm suits perfectly for my data and for my application. So that's the job of a ML engineer or a data scientist. So we're going to move for an interesting area next. So Shristi, we have any more questions?
Yes, we have additional questions.
Yeah.
So there's one question that reads as per facial recognition, could you explain to us how good accuracy can be achieved in large data set, not including 3D recognition?
Okay. Right. So in facial recognition, so I'll give an answer like this because facial recognition is a very complicated thing because the images that we get from the mobile camera can have very big distortions based on the lighting as well as we'll say you wear specs like me. So or you wear makeup or you wear hat kind of thing. So those are the distortions that can happen with your image. So you need to have a very big data set that can train on this. But the case is, uh, when it comes to image recognition, like in ImageNet dataset, uh, machine learning or deep learning algorithms have achieved near to 97 or 98% accuracy on that. But when it comes to the facial recognition, that based on the processing power as well as the data set that you have. So I'm pretty sure in most of the cases it would be nearly 90% or like more than 85% when it comes to facial recognition. But the case is the data set size. There are some algorithms that came recently called fusion learning or learning paradigm that can learn the images with few number of examples. So if you go for that kind of algorithm, so you can mostly achieve more than 75% accuracy on that. That is purely based on your data set as well as the computation power plus the complexity of the algorithm that you use. You can't say like directly, okay, with using this algorithm you can get 90 accuracy. So you can't tell something like that. That is purely based on your context.
Thank you, Haritha. We have another question.
Mm.
So, this question asks if ML can be called statistical AI, and what is the difference between statistical AI and classical AI?
All right. Uh, I'm not. I'm not a big fan of that term statistical AI. We can't say machine learning is something with statistical AI. So main difference between statistics and machine learning is the way the computations is going on and the number of data that has been trained on with that. And the next big thing in big difference between statistics and in AI, sorry, machine learning is the algorithms we use. So in statistics, what we normally do is we have the data that we have in the current context, and we do search for the similarities and dissimilarities between that, or we do kind of like vague analysis on their mean, median kind of thing. We give kind of like a description for that data based on the statistical methods that we have. But in machine learning, we don't stop just giving a description for that data. We see the future from that. We do a prediction from that, where statistics is not able to do. And the next thing is, one main difference between machine learning and statistics is the number of data points that we're going to deal with and the way that we're going to deal with that. We'll say you have a stream of data is coming into a system, a data stream. So statistics is not able to handle that streaming data, right? But in machine learning, there are separate methods that can handle streams. So those are the main two differences between statistics as well as in machine learning.
Thank you, Haritha. So we have another question. So this question asks that how are we able to select the perfect algorithm for any kind of problems, and how do we know that which algorithm is going to give a good accuracy for our problem?
Great, that question. So in a practical perspective, what we normally do is when we think, okay, we have a the first thing is to figure out whether this is a classification problem or whether this is a regression problem. That is the first thing that need to be figured out first. There's no specific way of that. That is pure intuition on looking on a problem. And the next thing is, okay, now it is a classification problem. Are we going to use decision trees or are we going to use neural networks? That kind of thing. So the best thing you can do is you have to see the complexity of data and the number of data that you're having. And the next thing is the validation accuracy or the accuracy metrics that you measuring is giving. You have to figure out how well the model that you have built is going to fit with your data, and you have to measure that accuracy or any accuracy metrics that you're going to fit. That means you might have to calculate the cross validation, or you might have to calculate the area under curve. That kind of mathematical calculations need to be done to see which algorithm is going to fit perfect for that. So you might have to use a couple of algorithms and see which algorithm is going to fit perfect for my data. So that is the way how we normally select the best algorithm that can move forward.
Okay, thank you, Haritha. I think we are good for now. You can continue with your presentation. So I'll be updating you about the questions as we move forward.
Great. So yeah, now we talked about machine learning algorithms and what sort of machine learning algorithms we have. And I would like to add one more thing. So all these algorithms are not just out of box algorithms. That means you can't get, we'll say you have one algorithm called an I-base or something called a decision tree. You can't just get that algorithm and plug for your data, and that's not going to give you a good output, right? So what you have to do is you have to tune the hyperparameters inside those algorithms too, because each algorithm is having a set of hyperparameters that need to be set it up on based on your data as based on your context. So those are the things that need to do in machine learning development. All right. So we talked about machine learning algorithms and all. So everyone has been talking about neural networks or how the neural networks are working. So it has been a very popular term out there. So what I'm going to do is I'm going to give a brief introduction what neural network is and how the neural network is going to work, because it has been one of the most popular things out there right now. So most of the image recognition or the voice recognition algorithms that you write now is based on neural networks. So starting from identifying an image of a cat and a dog, there are complex neural network algorithms that have built even to identify your face. So for an like very vague way, if I can say, you have a set of label things or images or voice or something. You just feed that into a network that is similar for your biological neurons that you have on your brain, and it's going to give you the output based on the training that has been done for that neuron. So if you know how the brain going to work in your, like it is having millions and billions of neurons inside your brain. Each neuron is accountable for doing some task, some valuable task. You are hearing this thing and you are thinking what I'm saying, and you are picturing these images. All this processing is happening inside your brains because of you have those neurons working together to do these complex tasks. So same as this way, scientists thought of, okay, if we can mimic the idea of these neurons into an artificial way, that is going to be a hit. So that's how this artificial neural networks came into the scene. ANN is not a big thing. That's a simple way of representing a single neuron that we have on our brain from a mathematical equation. We have a set of inputs that coming in. We have a set of inputs that coming in from the left-hand side, and we're going to sum up those things, and it goes through an activation function. I'm not going to explain all those mathematical terms of function that is called an activation function, and it is going to give you an output. So this is the way that scientists thought of, all right, we can represent our neurons that we have on our brain in this mathematical way. This is the very simple term which is for a single neuron. But think, in our brain we have millions and billions of neurons that is interconnected in different ways and different architectures. So that is why people came up with the next idea, which is called deep learning, which has many layers of this kind of neural networks. So that is how the neural networks came, deep neural networks came. There's no big difference between the vanilla neural network and deep neural network. The only difference is the number of layers and the way they have connected for each other. So in a very funny case, you can think of the normal vanilla neural network as a thin crust pizza. When it comes to a deep neural network, it's kind of like a deep pan pizza, which is having many things together, mozzarella cheese and veggies and everything together in middle of those crunches and crust. Then that is kind of the main difference between the vanilla neural network and the deep neural network. Right. So the next big thing is everyone is telling we need to have a very big computation power to do these things. And why a big computation power? Because all these operations that's happening inside these neurons is matrix operation. If you know the matrix operations that you have done in your mathematics, so each of these operations that happening in these nodes are matrix operations. So think of a neural network which is having millions of parameters, and it is having millions and billions of calculations to be done there. You know, from your normal computer science, in a normal computer or a laptop you have is having more like 3 or 4 processors inside. I mean, like the physical processors inside. Each processor that is having on your machine is able to do only one task at a time. That means to do that kind of big matrix calculations, which is having millions of calculations to do, it will take weeks or months. So as that, the only option is to go with parallel programming, which is having the ability to do many calculations at once. At that point, you can use a GPU, which is using for gaming, to do that calculations, because the GPU or the graphical processing unit is having tiny cores which can do simple calculations parallelly at once. For an example, if you have an NVIDIA 940MX on your laptop, that is having 384 small cores that can do calculation. So that's why you need a GPU to do deep neural network training or the deep learning kind of stuff. Right. So the next part is going to be super more interesting. So Srishti, any more questions that we have till now about neural networks?
So we do have a new question.
Mm-hmm.
So, okay. So the question reads as, can we use data mining tools, for example, Orange, for selecting the perfect algorithm?
Uh, in a way, yes. I haven't used Orange a lot, but in some cases, yes. The tools like Orange, Weka can be used for selecting the algorithms. But the case is, it is not going to select the algorithms at once. That means you can't put the data and say, okay, Orange, like just select the algorithm. What Orange is going to do, or the Weka is going to do, it's going to tell these are the evaluation matrices I have calculated, and you have to select the algorithm. But there's a new paradigm called automated ML that you can use to give your data, and automated ML will select the best algorithm for you. But it's pretty new. There are few platforms doing that, like Microsoft Azure is having automated ML engine. So there you have the ability to select the best algorithm. Yeah,
Thank you. So these are all questions for now. You can proceed with the presentation.
great. Uh, the next things. So you heard like what can be done through AI or the machine learning, and you will be looking forward to get into this space and how to start and where to start. This is the question many people ask from me. Like, okay, I'm pretty much interested in AI and machine learning, and I need to start. I need to do ML. I need to do some experiment with some data, and I have a like project coming up, and I need to learn this thing. Where to start? All right. So this is the way you can start. Yeah. Uh, the first thing is to get familiar with one of the languages that is widely used in machine learning space. So the languages which is more familiar with ML engineers as well as more popular in this space is R and Python. R is more popular with statistical people previously, but it has now moved forward with machine learning too, because it is having some machine learning packages too there now. Python, previously it was used mainly for low-level programming and some doing some IoT stuff and all, but now Python has been the most popular language used in the machine learning space. Uh, I have not seen anyone who's moving forward without doing Python on ML space. So the first thing is to learn one from these languages, and my preference. So like my love is with Python. So uh, I'll definitely like recommend someone who's starting machine learning to learn Python. So that's my preference. Because why I prefer Python more than R, if someone asks that question. So the case is Python is having the ability to do the other stuff too. Because we'll say you want to make this machine learning model into an API, which is going to be a part of an intelligent application. That means a REST API. You can use the Python commands like Flask API or something like that to build that too. So that is there's a very good compatibility with prevailing systems when using Python. So that is the first thing. If you want to start ML and AI, the first thing is to getting familiar with one of these languages, R or Python. So you can do this thing by learning yourself using some online courses, because there are pretty much very good online courses out there, like from DataCamp and many places of Python and R courses there. All right. Next thing. So we'll say you know Python, you have done Python. And what are the machine learning packages that you need to be familiar in Python? Because in Python, there are many packages out there. So what are the things that you need to know? So these are 6 main packages I have put there just to make sure that you know these packages if you want to go forward with ML. So NumPy is the basic numerical calculation package. SciPy is also an extension for NumPy, which is having more scientific calculations and all. Scikit-learn includes almost all machine learning algorithms that you have there, that you can train the models and you can do the evaluations, build evaluation matrices, and everything is there. Pandas, a pretty good tool for managing tabular data, or the data comes with rows and columns. That is a pretty good thing to use, pandas. And the next thing is matplotlib, which you can use to do visualization. Some people ask me, okay, why are you going to code something to do a simple visualization? You can use Excel or something like Power BI or something like Tableau. Why you do these things? Yeah, in a way, yes, but there are some scenarios that you can't use Excel or Power BI or Tableau for that. There are some complex scenarios you have to go with pure coding methods, so you have to learn Matplotlib on those occasions. We'll say you have image that you need to visualize some points on an image and make a video out of that. So you have to use Matplotlib on that. All right, and the next thing is Jupyter. If you going to start machine learning, strongly recommend you to use Jupyter as your environment because it allows you to code on your web browser and save that thing as a notebook that you can refer at lately what was your input is and what was your output. So Jupyter Notebooks is a very good platform to go with and start with machine learning. So all these packages, if you have installed Anaconda on Python, Anaconda Python, so almost all these packages are there. No need to install from one by one. So if you starting machine learning, I would suggest you to go with Anaconda because that's pretty easy to configure and no need to worry about so many package dependencies and all. All right, that was about machine learning. And the next thing is about deep learning because everyone is moving towards deep learning and everyone is eager to learn what deep learning packages are and what deep learning methods that we can use. This is a simple intro kind of thing. So I have put almost all the deep learning, not all, like many deep learning frameworks out there that we can use. So from this, TensorFlow is from Google. Microsoft introduced something called CNTK, which is not a good thing. So it is not popular out there. MXNet is from Amazon, and NVIDIA Digits is from NVIDIA, which supports CUDA. And Chainer, Cafe2, Torch, all those things are based on C++. Theano was also a Python machine learning package which has been depreciated recently. Keras is kind of like a high-level API which runs on top of TensorFlow or Theano, But because of Theano has been depreciated, I'm not sure whether Keras is supporting Theano or not right now. But many people who start deep learning, they start with Keras on top of TensorFlow, which is a okay combination. But PyTorch is introduced by Facebook Research. So Facebook Research introduced PyTorch, and it has been few years now, but it has caught a lot of attention in the research as well as in the industry. Many people have moved towards PyTorch, and everyone down there in the research arena also using PyTorch. So if you ask my preferred deep learning platform, what I use is PyTorch because it's pretty much easy and more dynamic and more fast. So yeah, those are the deep learning frameworks. So don't be be in a hassle. So these are the packages that you can use on Python to start with machine learning. And if you want to move with deep learning, these are the packages that you need to see. But I'm not suggesting you no need to learn all of these things. You can't do that. So I would say just pick one from these, whether to PyTorch or TensorFlow with Keras, so you can move with that. You can live along with that. But these packages you need to know. You must know these packages. And from these, just pick one and move forward with that. So that's about the technical environment and all. Why these packages are good in like deep learning is because these are supporting GPU accelerated computing. So in deep learning, you need to do a lot of calculations. So these are supporting deep learning, like GPU based calculations. All right. The next thing is the theoretical approach. So you need to have kind of like a theory knowledge on what sort of things going on. So this one, the machine learning course by Andrew Ng. So offered from Stanford out there. This is one of the most popular courses in Coursera. So you can follow one of the course like this on Coursera, and you can get a good idea on the theories behind machine learning, which is pretty much essential on moving forward with that. Right. So I have covered some basics on how to start the thing and what sort of things you need to do. The first thing is you need to know a good language like R or Python. And if you choose Python, I showed you some packages that you need to know. And the next thing is if you're going to move for deep learning, so pick one from the packages that I have shown you and get a good theoretical knowledge from this. And one thing I forgot to mention is start with some sites like Kaggle.com, which is having examples plus experiments that you can do there, and it will increase your knowledge while learning. So those are the things that you can do. So Srishti, do we have questions from that part?
Actually, I'm looking into it. So, okay. So we have one question that says, can we expect better result applying advanced algorithm than basic algorithm to the same problem?
No. My simple answer would be no. The case is this. You can't say that exactly, but in some cases, yes. We'll say you have a complex image recognition model, and you just put a simple neural network to do the classification. So you will get an accuracy of, we'll say, 60%. But when if you put a algorithm, something like a neural network, something like ResNet 150 or ResNet 50, something like that, so you'll get a very good accuracy. So that is one case. But in some cases, if you put a very complex algorithm for a small amount of data or a simple problem, you'll ended up overfitting your problem. That means you'll ended up like it is something like killing a rat using a rocket launcher missile. So that doesn't go with whether the algorithm is complex or simple. That does go with both with algorithm plus the data.
Thank you, Haritha. We have another question. So this person asks, how is data science and machine learning related?
All right. So how does data science and machine learning related? So the first thing when we have the data is before applying any machine learning method or machine learning algorithm, what we do first is we first do some kind of like a data science analysis or data perspective analysis to see the shape of the data as well as how this data is going to behave. So this is the relation between data science and machine learning. And most of the steps that we do before building a machine learning model, like data cleansing, data normalizing, and all those things are under data science, right? When it comes to machine learning, we move one forward further and see how this model is going to be in the production environment, how this model is going to be inference in a production environment, how this model can be deployed on a mobile computer. So those things are the aspects that we look on machine learning, not only the data science perspective of cleansing and all. So what we can do, what we can say is data science can be the first steps that we follow in machine learning pipeline. But then when it comes to machine learning, we have to think a lot on production environment as well as on the deployment.
Thank you, Haritha. The another question I have for you is, what does depth of a neural network mean?
Sorry, what does?
Depth of a neural network mean?
I couldn't get. Yeah. What are the spellings?
Depth, D-E-P-T-H. Depth.
All right, depth. All right, yeah. what is the depth? Sorry, what is the depth of a neural network means? What is the depth of a neural network means? How many hidden layers that you have in between your input layer and the output layer. So that is the depth of a neural network. If the depth is 1 or 2, we normally say that is a shallow or a vanilla neural network. If it is more than 2 or 3, we then call that as a deep neural network. Depth in a neural network means how many layers that we have between the input layer and the output layer.
Thank you, Haritha, again. So we have another question. So this person asks if statistical knowledge is must for understanding machine learning algorithms in case if we need to refine or debug the machine learning model.
Uh, where you need the statistics. So you need the statistics to have an idea about the data. That means you need to have a knowledge on statistics in both cases. One thing is when you're refining the data and when you wrangle the data in the first parts of building the machine learning pipelines, you need to have a statistical knowledge. And then when you're evaluating the models that you have built, you need to have a good idea on statistics to understand the evaluation matrices and all that you have built. You need statistical knowledge in both of those aspects.
Thank you. So we have another question. So this person asks if AI is a danger to the humankind as shown in the movies.
Okay, so I'm going to answer that question at the end for sure. Like, make
Okay.
sure that you ask that question again.
Okay, I'll ask it again. So
Yeah.
another question I have for you is, so this person says that the major problem with doing a deep learning project is collecting data. So how do we deal with low data availability?
Yes, that is a good question. So, how to deal with low data availability in deep learning problems? One thing you can do is data augmentation. You can follow many methods like, well, say you have image data, you can use rotation, jittering, you name it, those kind of data augmentation, and you can deal with the problem a little. And the next thing that you can use with like less data is using a less complex model, but not recommended at many times. And the next thing that you can do is you can move forward if you have a very less amount of data, but still you need to get a good result with the data. The next thing that you can go with, one thing is semi-supervised learning, or else you can go with some paradigm like few shot learning that can deal with few amounts of data, semi-supervised learning or few shot learning.
Thank you, Arita. So this is the last question for now. So can we start machine learning without going through the mathematics behind it?
Uh, no. Simple answer is you need to have a little bit of, or like at least a little bit of mathematics knowledge to understand the thing, because else that is going to be just you get the algorithm and you put the data and you say, okay, I have 80% accuracy, but the model might be overfitted or underfitted. So you might have to have a little bit of mathematics knowledge to go forward with that.
Thank you, Haritha. So over to you. You can continue with the presentation now.
All right. We got very good question. So we're going to move forward and see what actually that we can do here and what sort of things that we right now have there on machine learning and all. Right. So this one, I'm not sure whether you can see all the images I have here. So if you search the internet about CRISDM, cross industry standard process for data mining, cross industry standard process for data mining. So this is a standard process where you have a problem in machine learning and you have identified, okay, this is going to be a classification problem. So I need to go forward and build the thing. We'll say you have your final year project and you have a set of data and you see, okay, I'm going to build a machine learning model with that. So what should be the procedure and what should be the correct way to go with that? So this is the way, or this is one of the major ways that people use. As you have seen in normal software development, there's agile methods, there's SDLC, normal waterfall methods and all. So this is the process that you can go forward with building your machine learning model. In the first one, you have to have a good business understanding. As I said previously, you should know what data that you have based on your business. That means uh, you can't do any machine learning model building without knowing the domain. You have to be at least good in your domain, else you have to hire up a domain expert to get an idea what this data is about and what sort of data fields this is having. So the next thing you have to do is data acquisition and understanding, where you acquire the data and understand the data. So data acquisition can relate with many things. That might be a stream of data that you need to get as data streaming methods kind of thing. That might be a data that is coming from IoT devices that you need to put into the cloud and get the thing out from there. And that might be some unstructured data that you might have to use some unstructured database, something like MongoDB or Cosmos DB to put the thing and get the things out there. So those are some data acquisition decisions that you need to take from there. And from there, you have to do data wrangling and cleaning. So this is a very important part. Normally, in our life, when as a data or a machine learning engineer, we have to spend 80% of our time on wrangling this data. That means data cleaning and those things get much more time than modeling the data. So I would suggest, if you want a perfect model, if you want a perfect system that goes with ML, spend your time in data cleaning. That is not a waste. So spend 80% of your time in data cleaning. That is not going to waste in the next steps. After you clean the data and do all those things, you have to go for the modeling step. That means you have to do data modeling here. That means you have to you choose some algorithm and to do the feature engineering based on that algorithm, and then you have to evaluate your model from there. This is a place I have told you about to see whether your selected algorithm is perfect with your data. So you might have to do cross validation, some kind of A/B testing to see whether your algorithm is perfect with your data. After doing this modeling part, you have to do your deployment. In the deployment, you have to see, okay, in which environment I'm going to deploy this machine learning model. In most of the cases right now, many people tend to deploy their machine learning models as REST APIs, which takes a JSON as an input and gives a JSON as an output. So that is a perfect way that matches with microservices architecture that software industry has been adopted a lot right now there. So that is a perfect way to go with. So you need to see whether you're going to containerize this thing or you're going to deploy this thing in some cloud environment where you're going to do those things. Those are the deployment decisions that you need to take there. So after doing this deployment, you might need to do a performance analysis and monitoring. This monitoring step is quite essential because we'll say you have a set of data that you have built a predictive model based on 1 year or 2 years of sales data, and you run the system for 1 or 2 years, and after that, the system gives you bad results. Why that happens? Because you have trained with a lot of past data. That means you have just trained the data with data which is pretty old. So you need to get the data which is pretty new, and you need to retrain the models. So that is where this monitoring stuff is quite essential and appropriate. So you need to do a monitoring when the model is deployed, and then it goes for the customer acceptance, or might be for your final year project acceptance or final year project plugin for this ML task. So this is the process that you can go with if you have kind of like a data, if you have any idea. So this, you can model your idea for this framework and move forward in your pipeline of building a machine learning predictive model with that. So you can just search this thing as CRISP-DM, cross industries standard process for data mining, widely accepted in most of the cases. All right. So that is all about machine learning and those things. This slide I put with the intention of many people ask me, okay, you told about AI and ML, and what are bots or what are chatbots? So chatbots is an application that operates as an agent for a user. That means you have seen chatbots out there in many places. You have chatbots in your banks, or you might have seen chatbots in Skyscanner, or some applications you just chat through your Messenger or chat through your Skype, and bot replies for you. You go for some websites, and the person that is mimicking there is not a real person. That's more likely a chatbot. So what chatbot does is it's not defined as AI. We can't say chatbot is a pure AI. So chatbot is something defined by NLP or natural language processing kind of thing. So it is going to understand your natural language based on the inputs that you give, and it is going to give you an output from that. But in the cases like intelligent bots like Siri, Cortana, or Google Assistant, they use AI components for voice recognition, natural language understanding, as well as for natural language generation in very few cases. So that is a simple, just an idea to get what chatbots are and those things, how those things going to work. All right. So we talked about like many applications and how the things going on and all. So many people may thinking, okay, we talked about Siri, Tesla, Dora 2, Google Assistant, and those things. Those are pretty big applications, right? So why we need to have this kind of pretty applications? Can't we do have machine learning and those things in simple applications? Yes, you do. This is a project that was done previously when I was working as a data engineer back in Sri Lanka. So what we did was we had an application, a mobile application that can scan documents, and they had the ability to read the text in those documents and understand the text and understand what are the names and entities that is having on those texts. That means names means we'll say you have the name uh, Haritha, or you have the name James, you have the name John. You have to have the ability to understand what sort of names and entities like Kathmandu or Pokhara. So you need to have the ability to get the names and entities out of that. So this is a pretty simple application. You can use machine learning and AI techniques down there to integrate in your application development. So no need to go further for like Tesla stage or for Google Assistant stage. You can always move forward with simple tasks like this, and you can leverage the power of machine learning onto these things. All right. So can you go for the few last slides? So any questions down there, Srishti?
Okay, so I am looking up the questions. So yeah, so we do have new questions flowing in.
Mhm.
So my first question for you would be to start a career in AI or data science, where should I start? What are some must do things for me? And which platform do you suggest? Coursera, Pluralsight, or DataCamp for starting to learn?
All right. So in that case, I'm not having a good idea on like in which stage are you, because that always depend on which stage are you in your studies as well as your outer knowledge on that. So I can't like directly suggest you to go for Coursera or Pluralsight or like Data Academy. So that is purely based on you, because some people has told me that machine learning course that Andrew is conducting in Coursera is a bit more technical, but that is covering everything. So the next thing is he was asking about which platforms and all, right? So I would strongly suggest to go with Python, because there is a good programming platform to go with. So other platforms, like that is a vague question, because there are many, like when it comes to platforms, that goes with many things. Computing platform, so many platforms. But as a programming language, you can go with Python. And for learning the things, uh, yeah, you have to choose which goes well with you, because if you very good with maths and all, you will be definitely can go with Andrew's course, because it's not that hard to understand on that matter. And the next thing is was asking whether to start with data science or machine learning. I would say data science would be a good thing to start with. Data science would be a good thing to start with, and there's no big learning curve of turning from data science to machine learning. That goes streamlined, so there's no very big learning curve between those two.
Okay, thank you, Haritha. So we have another question. So can you give a brief information about deploying deep learning model in Django frame?
In Django frameworks.
Yeah.
Okay, yeah. So Django is a framework that mostly used for web application deployment. So what we normally do when we deploying the models, we normally make that thing a package, and mostly we use containers. What we do is we get the model and make a pickle file out of that using Python, and then we build kind of like an API, and then we plug that thing as a REST endpoint, and that is going to be might be inside the Django or might be a separate service that we're going to use. So that is how we normally deploy the models, or might be we move for some uh, mm, web means like AWS or Azure or some cloud environment. So that's how we normally deploy the models. That is purely based on what kind of requirement that we have. Because in some cases we have not, we don't have the ability to run a Django server or somewhere out there. Because in some cases we have to deploy on very tiny edge computers, where we might need to use a cloud computing platform and give the internet and use that thing by there. So that's how we normally do. Mostly what we do is containerize the thing and open up as a REST API.
Thank you, Haritha. So I don't know how much this question would be related to our topic today. I'll read it to you, and you can decide if you want to answer it or not. So the question says, Google has recently released Google Duplex. So can you please explain the artificial intelligence behind that? So the details can be what they have used and what process or method they might have used in creating it.
Okay, Google Duplex. I'm gonna see, yeah, what that is, because Duplex, right? Okay. That currently. According to Wikipedia, Flex is a client-server media player system plus an ancillary software suite. The Flex Media Server desktop application runs on Windows, Mac OS, and Linux. All right. Okay. So Google Duplex is kind of like a voice recognition thing. So yeah. Uh, I'm not sure what sort of algorithm is running behind that, but most probably it should be using some natural language understanding. That means voice recognition. Plus, not sure whether they have natural language generation, because it's going to generate some voice also. Uh, but I'm pretty sure they use some natural language understanding using some NLU engines that might be based on BERT or something down there to understand the language. Not sure what sort of like big technology is going out there in the behind.
Okay, so Haritha, I have another question for you. So this question is a question about a project I think a participant here is doing. So the question asks that how would you build a diabetes prediction project, from your perspective, using a supervised algorithm or an unsupervised algorithm?
That is purely based on the data set that you're having. If you are using the most famous diabetes data set that you have on the internet, not sure what a PIMA data set or something, that's the name of that, UCI reports. So that is a supervised machine learning problem. But if you're not having the labels there, so you might have to go with unsupervised learning problem. So that is purely based on the data set that you're having. If you have the labels, definitely go with supervised learning. if you're not having the labels, you might have to go with unsupervised clustering kind of stuff.
Okay, thank you, Haritha. So these are all the questions for now. So you can move forward. Over to you.
Okay. So yeah. So the next thing is there was a question about what I'm doing and what sort of activities that we do right now here in my research. So my research is about deep learning for sports analytics, basically on the computer vision, because Australia is a sporting nation. Here we are pretty much crazy on sports, many sports out there. So what we do here is we analyze the body movement patterns of the players to get the strategic decisions. So that is purely based on computer vision and mostly video analytics. What we do is we analyze how the pose of the players are going on. We'll say you have a tennis player who's uh, going to do a smash, or a volleyball player who's going to do a spike. So we're going to analyze their movement patterns and how their body joints going to move, and is that effective or non-effective, and is he putting so much effort on that, and those things has been calculated using their body joint movements. The case is you might going to think, okay, this can be done from IoT sensors. You just plug some sensors out there and you get the things. No, you can't do those things because that is not allowed in a sporting environment. You have to do those things on purely through the video recordings that you have. Mostly we do post video analysis as well as real time video analysis on how the players behave and how the game is going on, and we use that data to build some strategical decision making systems that get strategic decisions. I can't like say you the exact applications that we have built, but there are many applications that comes up with AIS or Australian sports that is using AI to do some prediction in many sports. So that is the main thing that we do in my PhD or in my research area. So I'm pretty sure there was a question down there about on asking like what you do on research and what sort of things you do. So that is my thing, mostly computer vision with deep learning and sports analytics with deep learning. Plus, I do research on cloud computing with deep learning too. That means how the cloud computing can be used on deep learning computations and deploying deep learning model deployment kind of stuff. Yeah. So that's going to be that's going to be end of my session. But I have a question down there that I didn't answer. That is whether the deep learning or whether this AI is going to be bad or good. Mm, so there is a wide discussion going on because some people say AI is going to be really bad, like in the movies, and in some cases they say AI is not going to be bad. Uh, uh, I'm standing in the middle because AI can also go bad. If you know the situation where there was a bot by Microsoft called Microsoft Tay that has been trained to answer Twitter questions, but ended up like training in a very weird way. So that kind of situations can happen. But the good thing is we have human in the loop in many and most of the cases. And I would suggest if you're building an AI system, there should be a way that human can be intervened. That means there should be a way where human can get the control in some case. So, but the next case is there's no such fear of having Terminator or something like that in a near future where AI is going to learn like very weird things, because most of the training that AI is going to do with humans. But the case is this: is if the human is going to build the AI to be bad, so that's going to be bad. So that is purely based on the training that you're going to do. That's something like making weapons. So that Newton has invented Newton laws. So some people has used that thing to send rockets and predict weather, but some people have used that thing to make missiles and destructive weapons kind of thing. So we have both sides. That is the same with AI. AI comes with a big power, but the way humans going to use that thing is the decision that we need to take. Yeah. Srishti, do we have any more questions down there?
Yeah. We do have more questions.
Yeah.
So, okay, so this is a fun one. So, Haritha, what fascinates you about artificial intelligence?
Okay. What fascinates me about artificial intelligence? What fascinates me about artificial intelligence is the way a neural network is learning by itself. So one recent application that I coded or built was writing or like structuring a neural network to learn what like which player is more important in a volleyball game just by showing them the video of the particular volleyball game. So neural network was able to predict or figure out which player is more important in that game, and that was the same player that a human expert was going to predict. So that was the main thing that fascinates how accurate and how complex and how miracle kind of thing that bounds with neural network algorithms. So that was one of the fascinating things that I have seen in AI.
Thank you, Haritha. Truly, the prediction does seem to be quite interesting. So we have another question. So, how would you use artificial intelligence for solving any kind of problems related to COVID-19 from your perspective?
All right, yeah. During this pandemic, I have seen many people have used AI to do some stuff. Recently, I saw like couple of hours before, I saw Singapore has predicted using their data scientists how this is going to be in the future. One thing we can actually do is we can use some like regression or some kind of analysis to analyze what sort of like number of cases and kind of things that can happen in the future. So that is one thing, and because for predicting numbers and see how much of effort that we need to do it on that. But the thing is, because that is going on an exponential curve, not sure how far these algorithms is going to work out. And the next thing is we can understand, each virus is having their genetic sequence. So one thing we can do is we can use AI plus bioinformatics to figure out the sequencing of those genetic sequences that would make the drug development and all those things easy. So I'm pretty sure some researchers are going on there to understand the genome sequences of that and get a good idea how this virus is going to mutate in the future kind of thing. So those things are under research, and those are very active research areas down there using bioinformatics plus AI. So they use machine learning plus genetic algorithm and those theories to predict what sort of mutations this virus can do cause in the future kind of thing.
Yeah, thank you, Harita. So, okay, so we have one new question. So someone from our participants wants to know that what type of algorithms should a beginner not miss while starting to learn machine learning?
All right, okay. Beginners should not learn, right?
I'd like to clarify. So the beginner must learn.
A must learn. Okay. All right. Okay. The beginner must learn algorithms. So I would say the pretty neat algorithms like linear regression and the classification algorithms such as decision tree and clustering algorithms like k-mean clustering. Yeah, those are like pretty neat algorithms that you must know as a beginner. Those are the must know algorithms, I would say.
Okay, thank you very much. So, okay, so we have a new one. So, okay, so this is a bit of a long question, I think. So, okay, so I'll read out to you just as it is. So,
Yeah.
when we feed the image data to our model that is collected from Google, Do those images need to have the same size? Can you brief me about image pre-processing?
All right. Okay. Yeah. When you're training, I guess this is about a classification problem or something, image classification or something. The images that you have, the size that you're going to feed the images for the model is purely based on the input that image is getting. As an example, if you're building some image classification model using PyTorch and using a famous framework like ResNet 18, the image size should be 224 into 224 pixels. So the images that you're getting in from Google might be in different sizes. That might be in 4K even. So that solely depend on the input size that you have on the input tensor of the model. So you need to do some resize operation on the image pre-processing stuff. So what we normally do is when we're writing, like this is bit technical, but I'm pretty sure that the guy who has asked the question might have the idea. So when we're writing the data loader, when we're training a model, we write a separate part for image pre-processing, which gets the image from any size and resize the image tensor. That means we are not using any Photoshop or something to do image resizing. What we normally do is we get the image and we use Python to resize the image and make it a matrix and feed into the model. So that's how normally the image pre-processing stuff happening in most of the machine learning use cases.
Okay, thank you again. So we have a new question. So the question asks if there is any library for working with medicine. So I'm a bit confused about this question as well because I don't think we have any library in Python or something about medicine. So I do think that the participant is asking about data regarding that
Uh, any library for what?
for medicine, for working with medicine.
Medicine.
Yeah.
Okay. Ah, yeah. I'm not sure there's any specific library for medicine, but there are some Python libraries which is used for biomedical applications. That means biogenome operations and those kind of like biogenome sequencing and those things. There are some Python libraries out there. And if you talking about medical image processing, so if it is medical image processing, that you can use any other image processing CV2 or something library to do many stuff. But if you're talking about medicine in related for biomedical kind of stuff, there are some separate libraries in Python that you can use there.
So thank you very much, Haritha. So these are all the questions that we have. So dear participants, if you still have more questions for our facilitator, you can still send in those questions on Slido. We are here to answer you. Okay, so please, Haritha, let's wait for a few minutes if we do get
Yeah.
additional questions. So participants, I repeat again, if you still have more questions to deal with, you can still send them in. So meanwhile, I'd like to ask the question myself to you, Haritha, because I received it via email yesterday from one of our participants. So you've been studying in Australia. So you've been doing PhD in Australia for how long have you been in Australia, and how was the journey for you to start with AI, to work with AI? How did it all start for you?
All right. Okay. So I did my basic degree or the bachelor's in Sri Lanka in Rajarata University of Sri Lanka, one of the major state universities down there. So I did my bachelor's and completed uh, 4 years bachelor's in IT. Then I was working as a Firstly, I was interning with Microsoft, and then moved for my career in data science as a data science and analytics engineer. And then I then moved for as a AI specialist or AI team lead for a startup. So that was my professional journey, which I used to do data science and stuff. So I started data science back in like 2015, doing my first experiments in 2015. So it's almost 5 years now. So yeah, that's how I started. But I came here back in 2018 for my PhD, attached with AIS and La Trobe University. So my journey to here was a full scholarship, which was funded from AIS to do my studies here while working as a researcher for them. So that's how I landed up here in La Trobe. It's almost 1.5 years now, like going to be 2 years in this July. So I have 1.5 years more to complete my PhD. Uh, if somebody is willing to do a PhD study or higher study in Australia, I would suggest you to look on the opportunities down there, mostly for the scholarships, because there is a very good way to study. Because I'd strongly suggest if you're going to study, not the migration purposes, if you want to study, scholarship would be the best option because that is going to be a very good thing because you don't need to worry about your course fees or something like that because they're going to fund you for your scholarship. The case is to land on a scholarship, you might need to have good records in your academia. I would say I'm not sure about the Nepal education system, but you might need to have a good class, like a first class or a second upper in your bachelor's, as well as you might need to have a good research record that has been like you might have to do some publication on your research and all, so that will impress uh, the universities here to attract you into a scholarship kind of case. So that is how the scholarships and all those things work. So uh, if I want to just share my contact details down there, if you have any problems so far that you need to get clarified, you can hit me on any SM channel down there on LinkedIn or in Twitter. So you can land there from my website that I have here, haritha.me, or so you can land there and ask any question out there from me. So yeah. So any more questions from there, Shriti?
So no, I don't see any new questions. So thank you so much, Haritha. So for the participants, before you leave, so I'll be posting the link to our feedback form on Slido in a minute. So I'm doing it right now. So I do suggest you that you can please fill our feedback form because that is going to help us improve. So that is going to help us, as in like girls in tech, uh, to improve on what we present you in the future in terms of webinar topics, in terms of our facilitators, and it's also going to help Haritha on a lot on like gaining insights on how he did on today's session. So I do think that Haritha did an exceptional job today. So I really did enjoy today's session because I am a person who is starting out with machine learning and AI myself. So I do highly hope that you had a great experience today. So apart from that, if you still have questions that you want to ask with Haritha, you can send the question in. So if you don't have any questions, please stay with me for a few more minutes because I'm going to post the link to the feedback form in a minute. So okay, so please wait for the link. Okay. So I'm checking the Slido. So yeah, so we do have a new question, Haritha.
Yep.
So the question says that which algorithms or areas can we look into to compare used products and brand new products and also to identify how old that product is?
Uh, all right. I guess this is going to be based on the image. If it is going to based on the image, that is going to be a classification problem or might be an anomaly detection. Because if you don't have any label things going on, that is going to be an anomaly detection problem. The algorithm that you need to use there, that differs a lot because in some cases you can use some state-of-the-art algorithms out there for image recognition, something like ResNet or VGG16. Those algorithms is working perfectly with images, but if your use cases are pretty much different, and if you have kind of like distractions kind of there, so you might have to do some tweaks for the algorithms like ResNet. But I have seen in most of the cases, uh, ImageNet pre-trained ResNets and VGGs are working better with this kind of problem.
Thank you, Haritha. So this is all okay. So we do have a new question again. So okay, so this question is quite similar to the one we had before. So this question asks, how much of mathematics do we need to know to start machine learning?
All right. Yeah, that's a pretty hard question. So you can say like you need this and that, but I would say you don't need to know all those complex number theories and all. No need to know those things. I would say your advanced level mathematics. That means a bit of a knowledge on statistics, probability theories, Bayesian theories, and yeah, and calculus in some cases, it would be good enough to go forward with.
So thank you, Haritha. So we don't have new questions. So thank you so much for being with us today. We had an amazing session with you. So best of luck for your PhD research. We hope that you do very well in the research, and we can hear more from you in the future as well. So to the participants, all of you who have been with us till now, thank you so much for joining in with us. So I again apologize for yesterday's mishap. So we hope that we won't be having such disturbances in the coming future, because we do have been researching about who those people were, and we have been able to identify who were creating the mishap yesterday. So thank you for all your well wishes and support. So we hope that you will also join us in our future sessions. So thank you so much. So I again request you to fill our feedback form. So that will help. That will greatly help us to improve in the future. So thank you again. So participants who do not have any more questions, you can drop the call. So that is all for today. So any other participant who still wants to ask something to Haritha, you can still send question. So we are here for a few more couple minutes.
Yeah,
So
and
if you
the
just
next thing is if any participant is there to drop any feedback for me, you're pretty free to drop me anything on my SM channels. So yeah, and if you have any more questions pretty specific to some area or any feedback for today's session, it's always welcome to message me on there, and I'll be like try my best to get some time to answer your questions there.
okay. So thank you everyone. Okay, so we are still here for a few more minutes. So all the participants who are done with the webinar session, you are welcome to leave the session. So if there's someone who still has question left, you can still drop the questions on Slido. I will relay the questions to Haritha. And if you do not have any more questions, you can drop the call. Okay, so we don't have any more new questions. We also have most of the people have dropped out from the call. So thank you so much, Haritha, again. Thank you for
Yeah,
joining us in this webinar. So I definitely want to hear more from you in the future. So I do hope that we can collaborate sometime in the future again.
yeah.
So all the participants who are left in the webinar, so you can drop the call. We are ending our session now. So thank you again. Thank you so much from the side of Girls in Tech Nepal and from my personal side. So this was Shrishti Shrestha, event manager of Girls in Tech, and Haritha, the MVP of Microsoft in artificial intelligence. Thank you all for joining. So this is all for now. Bye-bye.